Well, have you guys learned about epoxides?
Oh.
You guys been covering these?
Oh.
Yeah, we have.
Yeah? Does it seem like this is something important on the test?
Yes, cyclic.
So he calls it oxacyclopropane?
Yeah.
Okay. The book calls it epoxides, but oxacyclopropane? Okay. That's a whole other big thing. If this seems like it's going to be important on the test, maybe we should move on to this? Okay. Okay, someone just tell me in words, what's the product of this reaction?
Propane.
Yeah.
Oh no. Yeah. Doesn't it want to?
How many carbons
A
do we have?
simple, no, it's just.
Two. Oh, we have
No,
two
it's-
carbon.
Remember, this is not a carbon. That's very tempting. This is not a carbon. So this is just ethane. Yeah. All that's going to happen is that this is going to protonate, right? All right, so that's one of the things that we've learned how to do with Grignards. Remember, this is not a carbon. That's a common mistake.
Yeah.
Wait, so it's just gonna leave
Who's going to leave?
NGBR?
Yeah, this is the reaction we've already seen a couple of examples of, so I didn't want to go through the whole mechanism again. Remember that the negative carbon is going to attack the hydrogen over here. Okay. So that was just a quick review. All right, and can anyone describe in words what's going to happen here?
The carbon from the ethyl is gonna attach to the semi-positively charged carbon that's attached to the double
Right.
bonded O.
And what type of functional group are we going to end up with?
Alcohol?
Yeah, I end up with an alcohol. Here's carbon 1, here's carbon 2. Who's carbon 2 going to be attached to?
Carbon 3,
Yeah.
Who's carbon 3 going to be attached to?
4, and the single bonded O.
And what's the O going to look like in the final product? I guess I should say.
Plus me? Wait, what would it be plus, what would be the, it would be like DMF or DMSO?
Oh yeah, so again, the solvent here would be an aprotic solvent. All right, so again, these reagents. So what's this oxygen going to look like in the final product? What type of functional group will it be? Okay, I didn't go through the mechanism here because we just did a whole bunch of examples of that. So I just wanted to review the basic reaction here. But again, notice how numbering really helps us to get the right idea. Just go one step at a time and ask who's attached to whom. What's going to happen here is this number 2 is going to have the negative charge, right? So the negative 2 will attach to the negative, will attach to the 3. Then the 3's got the 4, and this is going to turn into an alcohol eventually when it protonates. That's just the same reaction we've seen a couple of examples of. Okay, now, let's see if we can figure out what will happen here. So let's actually go through the whole mechanism for this here. That's good.
Could attack either.
It's symmetric, so it doesn't matter. That's good. put in some numbers. It's always good to number your carbons.
I'm not sure where this
Let's
arrow,
number all the carbons.
does this arrow match up to the O to make it go down or to the bottom carbon?
Let's see, so who's at the tail of this arrow?
The
And
minus
who's at the
of
head?
carbon. Oh, the O, because we're going to change that to negative and so.
Now you have to rethink that over there. You're having trouble with that arrow. You have to figure out what that
I
arrow
don't
is.
This isn't a
get
negative.
how many.
This is just a negative.
This arrow, sorry, this one here.
This one?
Yeah,
Coming up one more.
yeah, so number both of those carbons. Right, so you saw that you dropped a carbon here, right before? All right, and again, the way to avoid that is putting in the numbers. Okay, so maybe we'll go through this together now. All right, looks like a lot of you had a lot of the right idea there. So again, I'm going to number all the carbons. Really a good idea to number in many cases, unless the things are really obvious. Now, one of the very first things we do is we change the Grignard from covalent to ionic. So we erase the covalent bond, and we put this negative charge over here. It's actually not really all that conventional to draw ethane as just a straight line. Maybe it would be better to call this CH3, CH2 minus, but what the heck, we're all friends. So we'll leave it like this. Okay, now obviously this is going to be at the tail. Who should be at the head of this arrow?
The corner carbon or the other corner carbon.
3 or 4 carbon. Why is that reasonable?
Because they're slightly partially positive.
Yeah, they got partial positive charges. Remember, who are good electrophiles? Carbons with partial or full positive charges. All right, so I think maybe 1 or 2 of you might have thought that the head should go in this oxygen, but that's not a good electrophile. A carbon with a partial or a full positive charge is a good electrophile. So that would give us here. All right, and now we have to break a bond. We got to break a bond, or we'd be exceeding octet. I think you guys saw we were going to break this bond. Which way are the electrons going to go in this bond?
The oxygen.
To the oxygen, because that's our leaving group over here. They can't go to the carbon because the carbon's already picking up electrons. We got to move electrons off of this carbon over here. Now, something very important here. This is a deep lesson about organic chemistry. It doesn't matter whether you've ever heard of oxacyclopropane before or not. Even if you've never heard of this before, you should be able to figure out what's going to happen just based on the charges and the arrows. All right, that's the key to organic chemistry. It's not based on the names of the molecules. It's based on understanding the basic logic that negatives attack positives. That's what the whole course is about. Negatives attack positives. Okay, now we have to draw the right product here. And again, I'm going to do it step by step. So I'll start with the number 1 carbon. Who's the number 1 carbon attached to?
Attached to 2 and 3.
Oh, careful.
Now
Number 1 is only
two-
attached to 2.
attached-
Who's the
two is
number 2
attached
attached to?
3,
Number 2 is attached to number 3. Now let's take our time. Who's the 3 attached to?
4.
Anybody else?
No.
No.
No, the number 3 is not attached to anybody else because it broke this bond. So don't draw this bond in anymore. And who's the number 4 attached to?
O minus.
Yeah, just the oxygen over here. So that gives us this. And you guys are already thinking about the charges. That's good. This guy's at the initial tail, so he goes from negative. Number 2 goes to neutral. And the oxygen is at the final head. So it goes from neutral to a big fat negative charge over here. So this is the correct product. I think some of you might have accidentally added or dropped carbons. Well, you're not going to do that if you number all the carbons ahead of time and then number the products and then go step by step. Okay, so that gives us this product over here. And then what's going to happen?
H3O plus, the oxygen will take a hydrogen.
Right, okay. Maybe to save time, I will just then
Add it.
put that proton in there.
Yes.
Okay, so in step 2, this proton is going to go in over here. You guys can do that mechanism on your own for fun. Okay, so that gives us this. So what type of functional group did we produce?
Alcohol.
All right, so this is a new way to make an alcohol, a different way that we hadn't seen before to make an alcohol. Again, one important lesson here is even if you had never seen this molecule before, you should have been able to figure out, based on our earlier principles and patterns, how this was going to react over here. Now, actually, one thing should have made you, so a couple things to notice here. Who was the leading group here?
There were none. Oh, the
MGBR.
MGBR. It wasn't really a leading group, it was just nice.
Now, the MGBR is not anything. Remember, it's just a counter
The
ion.
oxygen was kind of a leaving group.
Yeah, this left this number 3 carbon, right? This left the number 3 carbon. This is basically, yeah, a substitution reaction. We substituted the number 2 for the oxygen, right? This is a substitution reaction. We substituted the bond to the number 2 with the bond with the oxygen. Well, that should make you, well, is this a good leaving group?
No.
This is neutral oxygen. We've seen that neutral oxygen is a bad leaving group, but this is an exception. So you need to know this exception. This is a case, so there's rules and there's exceptions.